Hi, welcome to Bar Math. Today I'm doing a series of videos on exponents. So my first question is, what is an exponent? And in reality, an exponent is a counter, something that counts. It's a counter that counts the number of times a base multiplies to itself. So a lot of times students start to see exponents as just a number that's multiplying to the base, but it's really a counter. So 5 to the 4th, so here's our base, the big number, and P is power or exponent. So 5 to the 4th is really the same as 5 times 5 times 5 times 5. It's not 5 times 4, it's 5 multiplied to itself 4 times. It's shorthand notation to make these long chains of multiplication sets simpler to follow. So 5 times 5 times 5 times 5, that's the same as 625. Usually if the number is under 1,000 or so, I just multiply it out. It's simpler to say 5 to the 4th when the numbers are really big, but when you're simplifying things, the base number sometimes is easier as well. Depends on how confident you feel with exponents. Okay, so that's what an exponent is. Let's talk about some of the rules. The first one, and this is the one that students have the hardest time with. A lot of students want to say 3 squared times 3 cubed. They want to multiply the 3's together and make it 9 to some exponent. But remember, it's all multiplying 3's. 3 squared is the same as 3 times 3. 3 cubed is the same as 3 times 3 times 3, and we're multiplying these together. So in reality, we're multiplying 3 to the 5th, or in other words, we're doing 3 to the 2 plus 3. When you multiply bases together that are the same base, you add the exponents. That doesn't mean if it's A, it stays A, and if it's 3, it becomes 9. The base does not change. Okay, so that's what happens when you multiply. Multiplying, add the exponents. What happens when we divide the bases? The bases have to be the same. None of this works if the bases aren't the same, and you'll see why in a second. This is equivalent of 7 times 7 times 3, 4, 5, 7, 5 sevens in the numerator, 2 sevens in the denominator. Fractions are just division, so anything with multiplication, division, no addition, subtraction is pretty seamless, which means every 7 in the numerator can divide with the 7 in the denominator. 7 divided by 7 is 1. 7 divided by 7 is 1, which leaves me with 7 cubed. Well, that's because it's 7 to the 5 minus 2. When you multiply bases, you add the exponents. When you divide same bases, you subtract the exponents. Okay, next rule. And I have these numbered rule 1, 2, 3. That's not intrinsically 1, 2, 3. It's based on my own numbering because I just want you to be able to keep it clear what I'm doing. Okay, so the next rule has to do with an exponent attached to parentheses. Well, in reality, what we're doing is we're taking 4xx times, negative 4xx times negative 4xx. Because that cubed says this whole parenthetical phrase is multiplying to itself 3 times, which really gives me negative 4 cubed and 1, 2, 3, 4, 5, 6, x to the 6. So how did we get there? We multiplied this in. We had negative 4 to the 1 times 3, x to the 2 times 3, which is how we got there. So this becomes a to the n, b to the m times n, because when it's attached to the parentheses, as long as there's no addition and subtraction, that's a whole different set of rules, a whole different set of videos. This n multiplies in a to the n, b to the mn. Now that rule works if it's multiplication or multiplication division. This, if I expand it, is 3 over 10 a, 3 over 10 a, which is really 3 squared over 10 squared a to the 1, 2, 3, 4, 5, 6, 7, 8, which again is that same idea. It's 3 to the 1 times 2, 10 to the 1 times 2, a to the 4 times 2. It's the numbers that often get skipped. So this n multiplies into both the numerator and denominator, a to the n divided by b to the mn. All right, the next rule, the examples here, let's see. A to the 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 1, 1, 1, 1. This equals 1. This also equals 8 to the 5 minus 5. We could either do it with the expanding or the subtracting that we learned up above. Either way, we get a to the 0 equaling 1. So my next rule of exponents states that anything to the power of 0 is 1. And it doesn't matter if there's a bunch of junk in the parentheses, anything to the power of 0 is 1. Anything to the power of 0 is 1. Because you have to remember that what's really happening is you're dividing something by itself, or you can think of this as 1 times a to the 0, because there's always an implied 1 there. Well, you're taking 1 and multiplying it, your counter says there are no a's, and so that just equals 1. Okay, so the next and last thing we're going to talk about for exponents is negative exponents. I have this great story about my son and how he once said to me all snarkily that negative exponents was division when he was very young. It was a cute story. But the p has a 1, the q doesn't. So this is really p over q to the 7th. Because a negative exponent, again, this is equivalent to q to the 0, that's our 1, to our q to the 0 minus 7. That's what negative 7 comes from. Well, that would be the same as q to the 0 times q to the negative 7. Or if we think about the subtraction rules of a to the n minus m is equal to a to the n over a to the m, this has to be equal to q to the 0 over q to the 7th. So negative exponent, I think of it as a switch, switching you between the numerator and denominator of a fraction. And it doesn't matter if you're in the numerator and going to the denominator or in the denominator going to the numerator, it's always going to be a switch. So a negative exponent in the numerator is a positive in the denominator. A negative exponent in the denominator is a positive in the numerator, and we don't need to write those ones. This is the one that trips students up the most, and so you just need to practice it or remember that a negative exponent is a switch, and it's all it does is it shifts between the numerator and denominator. It means division, and in fractions, division is the opposite. Numerator divides denominator, denominator divides numerator. That's our division bar, and so the negative, to get rid of it, you switch it. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you in the next video. Thanks!